All right. Thank you very much for joining. Babatunde David Aremu. I'm from Nigeria. I founded the Geospatial Hub. It's a small startup. Basically, what we do is to teach in Nigeria and across Africa. We found a learning gap and we found a skill gap. So, in summary, what the idea is all about is we're trying to bridge this gap, and we are trying to make people in our continent, get up to speed with the geospatial technology. Basically, that's the introduction. So again, I'm Babatunde Aremo, and I'm also a student in this program. I'm on my second year. So I see a lot of us, we have some experience with Google Engine, and some of us do not even have any experience. So initially, we are meant to, from the program, the workshop. Where's the workshop? On the, I have to go down. Yeah, like I want to go to the sessions. All right, so we are meant to talk about exploring sustainable solutions with Google Earth Engine and um, the recent events in Libya about the flood. We'll eventually develop a code and quantify what has happened over time. But I realized uh, we have so many beginners, and if you just start writing codes, then it might not make sense. So I just thought it would be good to like introduce us to Google Earth Engine first, and aside introducing us to Google Earth Engine, maybe a little beginner-friendly codes before we get to the more um, stuff. So I would appreciate it if you follow my YouTube. It's just special hub on YouTube and all other social media platform. And if you want to learn for free and earn certifications, you could just go to the geospatialhub.com and you see the previous courses and maybe um, blog posts. All right, cool. So over the last couple of years, there have been an explosion, I mean, a really explosion of Earth observation data. Satellite pop up every year. I think I was reading an article recently, and Elon Musk was saying he wants to launch about 5,000 satellites within, I don't know if it's this year, but I mean, like, there's so much explosion of Earth observation data, satellites in the space, and they're just taking data about the Earth. And I have a video here. So this video basically, I'll play the video now. Probably speed it up a little bit. I'm sorry. All right, so I'll speed it up a little bit so we don't waste our time on the video. But basically, what this video is trying to show us is trying to show the explosion of the satellites we have in space. You can see from like 1960 till, I think the video was till 2016. And you see the volume of satellites that are actually monitoring our Earth. And all these satellites are basically collecting information about Earth, probably about weather, about land use, whatever. It's capturing details about the Earth, and you can see how much it's getting, like, as the year moves by. So obviously, our computational resource on our computers would not be able to like deal with this amount of data. This amount of data basically too large for us to like deal with on our phone or on our laptops, or so we need to there's a need for cloud computing. And give me a minute, please. All right, so there's a need for computing. So basically, I have on my phone here that the large amount of data is well above the storage capacity that the conventional data centers could provide, because it is incredibly difficult and costly to be continuously upgraded and scaled to ensure a growth rate of petabytes per year. So basically, this data, it's like way too much, and it's not something that um, we can we can basically use our computational resources on our computer. I don't know, any one computer here with the highest RAM will probably be 16, and probably maybe 1 terabyte or 2 terabytes, and that's all, But and maybe your processor, I don't know how much your processor is, but you want to do computation like on a planetary scale, and obviously we cannot use a computer. One of my colleagues came to meet me while we were in the conference earlier, and he said he wants to get the NDVI of the last 30 years. I mean, if you want to do this manually, I don't know how long it's going to take you, but I can guarantee you maybe less than 10 lines of codes, you run this in 5 seconds and you get this data for the last 30 years. So it's really useful for us. And I just want to introduce, earlier in the conference, Dr. Wu said a little bit about cloud computing, so I won't just waste time. So basically, what is cloud computing? So it's basically trying to use other people resource, right? Like I've been stressing on our computational resource for our computer. It's not enough. So basically, you need storage, you need processing, you need all this things faster. Then you move to the cloud and you access what a cloud provider has basically made available for you. So basically, that is what cloud computing is. And I thought that it would be also interesting to talk about the different type of cloud computing we have. We have infrastructure as a service, we have platform as a service, and we have software as a service. So all this English here, it's like a lot. You could read it, but I won't be explaining this way. But I just want to give you this kind of understanding about what infrastructure as a service is. So imagine you rent a kitchen, and the kitchen has the stove, it has the meat, it has everything you need, but the kitchen is not yours. It has everything you need. All what you do is to just go to the kitchen, you pay for using the kitchen, right? And you use what you want to use in the kitchen. Maybe you want to cook rice, everything is there for you. Then you leave, right? You don't care about maintaining the kitchen or stuff like this. So basically, that's like an whole infrastructure. They're providing an infrastructure as a service to you. Now, when it comes to platform as a service, it's more like customized. It's say, let's use the same kitchen example, but now you want a burger. So the kitchen setup, it's optimized to give you a burger. You cannot make a rice there. You cannot cook rice there. It's like it has grills, it has bread and all these things just for burger. So that is the platform as a service, like to bring it down to make you understand properly. Then the last one is software as a service. So software as a service is just like, then you go to a restaurant and you say, I want a burger. You just go to the front, maybe the burger to go. You just get the burger and you leave. You're not concerned about cooking. Like everything is scaled down to just software for you to use. So basically, those are like the cloud computing models. We have the three of them, and I also want to do a little bit of comparison between the traditional computing and the cloud computing. So the first one we have here is the hardware requirements. So basically, um, with traditional computing, I mean like on your computers and doing stuff like this, you need to buy very powerful hardware. For example, if you want to like do something really computation expensive, you need really good hardware. Like you can use my hardware basically, but with cloud computing, all you need is a very good internet connection. Maybe not very good because everything is like on the cloud, but you need stable internet connection. Then software requirements. Right now we are using Google Earth Engine. We will not be installing any software on our computers. We'll just use what is available on the platform already. So it's like, to me, Google Earth Engine is more like a platform as a service because we are going to the platform and we are accessing the service on the platform. So traditionally, you need to install a software, and stuff like this. Yesterday, when we had the presentation from one of our professors at Esri, he said very soon we won't be installing anything on our computers anymore, and everything will be on the cloud. So this is where we are like moving to in the nearest future. And storage, like I said, we have like storage capacity limits. For example, my computer is 256 gig. It's like really small, right? But because I'm working on Google and I'm using their cloud, I'm buying from them. I don't need to. I think I buy 100 gig every month, so I don't need, and it's really cheap, right? So I'm not worried about the space on my phone, or if I want to do something, like I don't care. They are providing me with the space and also time. Like I said earlier, the friend that came to me earlier, he wanted 30 years of data. Imagine you are using Landsat. Imagine there's no Google Earth engine. And you're using Landsat. How long do you think it will take you to um, get this 30 years of data? The first thing you need to do is to um, get your area of interest. And unfortunately, sometimes if you I don't know if you've worked with Landsat before, but if you're working with Landsat, if you want to download the data, it's always in some part and row, So sometimes, unfortunately, your area of interest falls between different parts and different rows. So you have to download like maybe 3 data sets or 4 data sets, and all what you need is just maybe let's say NDVI, like my guy's use case, you just need 2 bands, right? So imagine you need 2 bands and you have to download images for 30 years. Really time consuming, the processing. Honestly, it's really difficult. But with cloud computing, it's readily available for you, and you just need to use what you want. And also, we have the data access and we have the cost effectiveness. I would be sharing this this with you. So if you want to like go over it and maybe read or something, then we have some cloud technologies that are available for remote sensing. We're basically focusing on Google Earth Engine today, and there's one from Microsoft as well. I've never tried it before. I've never tried the one from Microsoft before, and I've never tried the one from QGIS as well. So today we'll be using a lot of Google Earth Engine. And this Google Earth Engine, how did it start? Like, what prompted Google to like give us Google Earth Engine? So basically, there was deforestation in the Amazon rainforest. I think I have the time lapse here. Right. So before we continue though, do we have access to Google Earth Engine on our computers? Because we'll be doing like a lot of exercise. Right. So if you look at this, it's loading. Just give it a bit. So you'd see the deforestation in Amazon rainforest over time, and it was a project by Google and the Cornell something university, and they basically wanted to quantify what has happened, over. um, basically started. And from there, they were able to, I don't know if you guys listened to Dr. Wu earlier. It was like, how come when you look at Google Maps, right, you do not see clouds? It's not possible because an average image you take is filled with clouds, right? So how did Google get a cloud-free image of the whole world and everywhere in the world? For example, if I go to say maps.com and let's just switch this to satellites. Sorry. All right. So how did Google achieve this? How was it possible to take the image of the whole world without cloud and everywhere feels like it's spring, it's summer or spring at everywhere the same time? We'll practicalize this in this class. We'll be able to like remove clouds from like a lot of satellite image, but how? How come? So basically, if you look at an image with cloud, let's just do Yeah. So I'm just randomly Googling a satellite image with cloud so we see what it looks like. So just envision, we've all seen satellite images. So just envision a satellite image, right? And now, good, we have it back. Okay, I think this is good. Yeah, this is good. So look at the image on right. Okay, my right, I think this should be your left. But if you look at the satellite image, for example, right? Okay, I'll just go back here. If you look at the satellite image, you know, our sensors in our satellite, for example, Sentinel or Landsat, they take the image of the same, if this is a particular location, they take the image of the particular location over and over and over and over again. So if the sensor fly over this place today, it's possible there's cloud. If it flies over it the next 5 days, it's possible there's no cloud. If it flies over it again, and you know, this data set is one thing they've had for years, since the 80s, right? Now, that is how they were able to create a cloud-free composite of the whole world. What they did was they took the median pixel. You know, the values with clouds will be white, and to have a very high reflectance, like the pixel value at that point will be very high. That would show you this place is a cloud. And now, if you look at this cloud, this particular one here, it has a shadow. Now, the shadow will have very dark pixels, and the pixels would have very low intensity values. Now, with these low intensity values, you can have an idea that this particular place is filled with is a cloud shadow. So now, if you can take a median, what is the middle pixel? What is the average value over time? With this, you can create a cloud-free composite of the whole world. And that is how we're able to have something like this, and it looks like it's spring everywhere, and there's no cloud at all. When you look at everything we have here, everything is just like really good. But in the real essence, like it's not true, like Dr. Wu said. It's just like a mosaic of like different images from different time frame. So going back to the presentation, so from 1984, an annual composite of the whole world was made to create a cloud-free mosaic. Today in class, we'll be like seeing how we can do this thing ourselves and remove so many clouds. There are also algorithms though, provided already by Google Earth Engine to remove clouds from images, but we'll see how we can use a mosaic to achieve the same effect. And doing this job would have taken 2 million hours of computation, and it would have taken about 66,000 computers. And Google did this in just 1.5 days. So it's really good, and it makes a lot of sense. And right here, I have some infographics about the data on Google. And if you want to, maybe this will be our first task. So can we go to this website and go to our hometown and figure out one change that has happened like over time? So just go to this website. I'll show the website again. It's googleearthengine.google.com/timelapse. So we'll be doing this exercise a lot. I'll be giving a lot of exercises, and please do well to do them. We would have like 10 minutes. We would have 5 minutes like time frame to do this. Every exercise I'll be giving, and so this is our first exercise. Go to this website and go to your hometown and try to figure out one thing that's changed over time. So if I go to this website, you can search you can search here, right here. So I can just search from because I'm from Nigeria, I can search Lagos, Nigeria, and I can show you one thing that's changed over time in Lagos, Nigeria. But this is your task, so I won't be doing it. So go to the website, and we have 5 minutes for that. The search bar is not working. Just zoom, just try to figure out with the zooms. All right, so anyone found anything, any change over time? Yeah. You found urbanization? Great. All right, so for people that do not have your computer here with you, I'm zooming to Lagos, Nigeria. I'm from Lagos, and I'm very certain that around the ports in Nigeria, um, there have been changes over time. Guys, if you look around here, you'd see some changes in the ports over time. Just keep looking, just keep looking. You see the construction of the ports, and you see some changes over time. So we have 3 more minutes. All right, guys. I don't want us to waste too much time on this. I'll just reset this timer because this is really not very necessary. We need to like move on to like the more important stuff. But I believe we can like do this on our own and see what has changed over time. So, what is Google Earth Engine basically? So, Earth Engine is a cloud-based platform for geospatial analysis on a global scale. You could like perform analysis on everywhere in the world all at once, and it basically reduces the processing time by utilizing Google's computational resources, and it has a huge repository of remote sensing data, basically. So why Google Earth Engine at all? So the first thing is, the first reason I have here, like, why do you want to use Google Earth Engine? It's free. It's free for academic purposes, and it's free for non-profits. And also, it hosts a lot of like satellite images that are available for you to just, use, and historical data set as well. So here I have a link to the use cases. So it's just earthengine.google.com/use /case underscore studies. So we can see how Google Earth Engine has been used over time, and like if this could probably share some ideas in you, and or how you could use Google Earth Engine for some stuffs you want to do. And also, um, to me personally, Google Earth Engine is remote sensing made easy because it basically simplifies everything you are doing. It simplifies your processes and it makes it look like you're doing a child's play, basically. And what someone has probably spent, you know, a whole 6 months doing, you just process it in 5 minutes, and it's really good. And it has an active user community. So you could go here to the group.google.com, and I'll be sharing this link with you as well. And you'd see people post like every other minute, like because this community is very active and people post questions and they receive answers, So if you're having issues with your code or something is not working properly, it's very beginner friendly, and people like want to welcome you to the community and always answer your question. You see, this question was posted yesterday and has like a reply already. This question was posted yesterday, it has 5 replies already, and sometimes your messages might not get responded to, but if you give it time or if you mail again, you would get responses. So the user community is very, very, active, and it has like an awesome guide. When I started out with Google Earth Engine, I didn't know anything. So all what I do is just go through the documentation and read, and try to do one or two things. So then this is the link to sign up for an account. I believe we have an account already. And this is the link to the data set. We'll be using this data set a lot today. We'll be exploring this data set. You can see Landsat, Modis, Sentinel, and other data sets available for us to use freely. Then I have this video here. This video is basically for us to just meet Earth Engine. So I'll play it and also increase the speed so we can like watch it in a minute. All right, so it's really cool, like what Google is doing, and all of the use cases. Then how do we use Earth Engine? So basically, I think it's time for us to get our hands a little bit dirty. So basically, you could use Google Earth Engine with JavaScript, and you could use the API available in Python. And I just discovered today Google is doing something new with the GE.core. I never knew that before until Dr. Wu mentioned it in the conference. So they're making it easier for you to use their APIs and resources readily available for them. So okay, all right. So guys, we'll start coding, and yeah, I'll just explain the interface. Guys, please let me have your attention, please. So this is the interface. This is where you get to do all of your work on Google Earth Engine. It has a map interface where you can pan around. You can switch to the satellite view. If you don't want the map view, you can go to the map view. And thank you. Your code saved here. Basically, you have the documentation. So in the documentation tab here, sorry about that. Is there a way to fix that? I will just manage it for now. We won't be coming here a lot anyways. So we have the script tab where like your scripts are shown. We have the documents where um, it basically has the documentation. This is really helpful. If you want to do anything, you can just come here, you search, what you want to do, and it's going to like give it to you. And we have this assets tab. So basically, this assets tab is basically if you have your own shapefile or you have your own raster, and that's the beautiful thing, right? Even with your own raster, you can import it and you can like use Google computational resources to work on it. And if you have your own shapefile as well, you can import your shapefile. You can clip an image to your area of interest and stuff like this. You can search a particular place. So we are currently in Castellan. You can search this is where we are, then it zooms to where we are. Basically, you can use this as interactive. It's not just to search for places, you can also search for data sets. I like working with Sentinel a lot, and it's going to, load the data set for you. So we have Sentinel data. And also, if you run a script, say I have something here and city, we are currently in Castellan, right? So now I can like get the link to this code. I have to save it first, save it, get the link, and I can share this code with you. And we can share our ideas on, oh, this particular line of my code is not working, something is wrong. You just need to share the link with me, and I can tell you what is wrong, or someone else from the community can tell you what is wrong. This is how you run your code. So if I say, for example, print city, and I run it, right? It shows here on the console. And when you have any tags, right, the tags, maybe you're uploading something to Google Cloud, or you are trying to generate any tags, you see the tags here. And this inspector is basically to inspect places on our map. So I just press the random location, and it gave me the longitude and latitude of this particular location. And if you want to reset all your codes, you could just press this to reset. I won't be doing that. And this is apps, like you could create Google Earth Engine apps, so we won't be doing that today. And also we have some geometry tools here. If I want to pick a point, I can basically drop the points here, and we can work with this geometry. We can filter our images to this geometry, or anything we want to do. So for just the people that are here that we don't have any programming experience, it's fine. I'll walk you through a little bit of the programming you need to code in Earth Engine. You don't need a lot of programming. In fact, if you don't know any programming, it's fine, because the API is the same thing, even if you are trying to use Python or you're trying to use JavaScript. So let's just do a little bit of, sorry, let's do a little bit of intro to JavaScript, just a little bit of introduction to JavaScript. So we have, the first thing we have is variables. So in JavaScript, if you want to make a comment, you just use 2 backslashes, or you can press Control and the backslash, and it would give you that. So we'll start with variables, right? So to declare a variable, you have to use the keyword. In JavaScript, right, to declare a variable, you have to use the keyword var or let. Yeah, but you can't use let, unfortunately, with Google Earth Engine. So we'll be using var. So we start with the city, and now we are in Castellan. So we'll say Castellan. So basically, this is a string, and the thing about JavaScript is when you want to end your, you have to put a semicolon to tell the interpreter that this is the end of my code. But the beautiful thing again is that you don't necessarily need to do that, because it automatically puts it for you. So pardon me if I do not remember to always put a semicolon at the end of my codes. I don't really do that. It automatically puts it for you, but you don't see it. So now we can also say population. It's also a variable. So I don't know what's the population in the city, but let's imagine we have, sorry, let's say we have, I don't know, I just have random numbers here. So this is the population in our city, and we can display this, right? To display this, we just need to use the keyword print, or the function print, and we can print city, for example, or we can print population. And if you want to run, you can press Control and Enter, If you press Control and Enter, it's going to run. I'll be teaching us like some shortcuts to like do our stuff faster. So when I press Control and Enter, you see the console is highlighted, and on the console we can see. Sorry, yeah, I made a mistake. Sorry. Thank you very much. So I'll do that again, and we can see the population. Yeah. So this is variables in JavaScript. Then the next thing we'll talk about is list. So this list is basically when we want to do our visualization, we need to always have a list. Like we have to put our visualization parameters in a list. So basically, a list is just a bucket basically that has so many variables in it, right? So to use a list, you need to use the square brackets. So this is what we'll be using to use our list. So let's just say list of the names of the people in this place, right? So we can have, I have the attendance, and I don't want to start typing names, but I'll just say ABC, and let's say another name is DEF, and you can, a list does not necessarily need to hold names, or it can also hold numbers as well. So this is our list. Okay, so I think it doesn't want me to use this name, so let me use an underscore. I think name is a reserved word. So let me just say names. So now we can also print this, but okay, let's print it and see how it looks. So print names. And when we run this, we can see we have this in our list. You can see, and the list is basically it's indents. So we can see 0, 1, 2, 3, and the item in this position is in position 0 is A, B, C, and the likes. Then the next thing we will need a lot when we are doing Earth Engine is the dictionaries. And to declare a dictionary, we need the curly brackets. So a dictionary can hold the list, it can hold the variable, it can hold like other stuff. We would also need this when we are doing our visualization parameters. So we can say our city data. So in programming, you can decide to write your stuff in camel case, or you can, if you want it to be more readable, you can use underscores instead of space. So I can say city data, or I can use camel case. So camel case is basically just capitalizing every word aside the first letter in the word. So I can say city data, and I can put it in a dictionary. So what information do we need about what information do we want about the city? So let's say we want the city name. For example, we want the city name, right? After the name, then you put like a semicolon, and the city name is, let's say, Castellon again, because we are currently in the city. And after that, you need to put a comma, always. You always need to put a comma. Then let's say the population, what is the population in the city? So I'll just give this pop we add here instead of writing it all over again. And finally, elevation. Since we are GIS people, what is the elevation of the city? And we say the elevation is 93 or 95, whatever. So we'll say the elevation of the city is 95. And now, one thing about dictionaries in any programming language is that it is not ordered, right? Our list is ordered. Our list gives you 0, 1, 2, 3, right? Like you could see here, we have 0, 1, 2, 3. But if you print a list, if you print a dictionary in Python or JavaScript environment, the order might be different. It's not ordered, basically. So I just felt I should point that out. And now we'll print our city data, then we'll see how our city data looks like. So you see it's an object, right? So some people also call a list an object, especially in JavaScript. So they are both objects actually in the real sense in JavaScript. So we can see our elevation, despite it's not like the first, despite our elevation is not like the first thing on our objects in our dictionary, it's the first thing that came out here. So it's not ordered, basically. It can arrange it anyhow. So that's what I wanted to point out there. And the final thing we'll be learning in the introduction to JavaScript is functions. We really need functions to like make repeated tasks really easy. So to declare a function, all what you need is the keyword function. And let's create a function to greet everyone in this class. So we can give the function a name, and we can say this function is to greet, and we can say it accepts a particular name. And we can just return something, right? Like every time this function is every time this function is run, we need it to do something particularly for us. So we can say hello, and we can concatenate the name. Name. So let's give this let's call this greet. And anytime we call this function, right, and we give it a particular name, we would say greet something, right? So let's print this. So let's greet the entire class, right? And we'll say greet, and we'll put class. So if I run this, you'd see hello class. So basically, if you like my friend earlier was saying he wants to get the NDVI for the past 30 years, right? So what we can do is we can create a function to calculate the NDVI for a single image, right? Then we can pass a collection into that function, and it returns the NDVI of the 30 years. So maybe not to do that, I'm not sure, but it depends on our time. I think we have just roughly an hour to end this. So this is everything you need about the introduction to JavaScript to be able to do this. Then I just want us to go through image collection, how we can filter image collection, because in Google Earth Engine, filtering is something very important, right? So like I said, you can basically just search any data set. So I said I love working with Sentinel. And if you search, you would see all the Sentinel data sets, and you would see uh, it's not like it's not really important. Basically, it depends on what you want to do. So if I search Sentinel again and I click on this, right, you can see the description. I'll just open this in a new tab, and we're about to start proper Earth Engine now, like about to start proper Earth Engine. So I opened it in a new tab, and now you can see this is Sentinel-2 dataset, and this satellite started collecting data from 2015 in June till date. So imagine having all the data sets from 2015 till date, like just you imagine what you can do with that data set. So now let's explore the data set. You can copy this line of code, right? If you copy this line of code, you can paste it. You can paste it in your code. You can paste it in your code, and we can say variable Sentinel2, and we can say it is equals to this, right? But instead of doing this, what I did earlier was I made an import. So when I search Sentinel2, when I search Sentinel rather, I imported this. So if I click on this, it's the same thing as clicking the import here. All right, so going back to the data set, we need to understand the data set, right? This is the description of the data set, and these are the bands. Really important, we know what band we are working with, and these are the image property. The image property is also very important if we need to perform a filter. For example, let's say you want to filter an image and you don't want a cloudy image. You want images that are less than 30% cloud, right? You need these properties to look at, oh, what properties am I going to use and how am I going to like filter with these properties? So basically you need to like study these properties, and time of use, you can also read this. So basically these guys provide us with a sample code, and if I copy this sample code, I can just basically paste it here. Let's just see what we'll be copying a lot of sample codes, then we'll delete the sample code and we'll implement it ourselves. So if I run this is a sample code, and it zooms to Lisboa, and with the sample code we can basically see all the images in RGB, like of the whole world. So if I keep zooming this, so imagine I give you a task, display the RGB image of the whole world for me. How long would you think this process will take you doing it manually on your computer, downloading satellite images? But we are doing this in the and do a particular request, and it returns the request to us. So it's still loading. You can see the loading bar here. But with this, it loads for the entire world, and within some minutes, we are basically processing the data for the whole world. So it's still loading, and it keeps, so each request I sent to a particular computer, once the request is ready, the computer basically displays it, like the Google servers basically displays the result back to us, and that's why you are seeing it loading, like each square is loading one after the other, one after the other, one after the other. So it's like a particular server, and it's like returning a particular result. So I don't want us to waste so much time on waiting for this to load, but basically you can see with the code we copied, we can get like basically images of the whole world already cloud-free and in RGB for us. So if we want to achieve this with our own codes, how do we get to achieve this? So we'll start with filtering our image. And once you are, for example, once you are working with Google Earth Engine, you don't need the image of the whole world, right? You need the image of just your area of interest. And your area of interest, you don't need image, like for example, we said this sensor has been taking images since 2015. You don't need images since 2015. You probably need image for a particular time frame, right? So we'll learn how to filter, and I'll just delete this in case you missed it, how I did it. And I would, here, I'll search for Sentinel. And when I search for Sentinel, we can see the Sentinel dataset is here. And basically, I click this import, right? So this is image collection, right? You can rename this to whatever you want, but we'll leave it as image collection. So let's just do something, right? Let's print, I want to copy the image collection, and let's print. I'm curious, what is inside this image collection? Let's print. So once we print the image collection, we'll see what it's going to do. So it's computing. All this is on Google servers. It's computing, and it says error. Anyone knows why we're having this error? Exactly. It's too much data. Like, come on. This satellite takes image of the whole world every 5 days, right? So the data is too much. Like I said, we don't need this much of data. We only need data for our area of interest. So that's why we need to perform a filter. Now there are different filters, right? So now we can filter by date. So we can say, you know what? I don't need all the images. So let's just start, right? And I'll do this. All right, so let's start filtering. I'll call this filtering. And let's start our first filter. We want to have a date filter, right? So we want to filter by date. Let me just call this date filter. And we want to filter by particular date. So if you want to filter and you don't know how to filter, all what you need to do is go to the documentation and press filter. So once you go to the documentation, you'd see a well-documented documentation on how you can perform filters. Now, what you need is the date filter, and this is the date filter. So if you click this date filter, you just read it. It's like concise. You don't have to read a lot of things. And it says filter a collection by date range, right? So we want to filter a collection by particular date range. So all what you need to do is to say the image collection, then you put a point, then you say filter, right? This is like a keyword. You have to always do this. It's a keyword. Then say we want to filter by date. Then you can say ee.filter. Now, I don't like typing a lot. All programmers are lazy to type a lot. So you can press Control and spacebar, it auto-completes for you. That is something very good Google is doing. So autocomplete, and now I can look for the filter I want. I want to filter by a particular date range, right? Now, I still don't want to type again. I'll do the autocomplete. Now, autocompleting, you can see it tells me when is my start date, when is my end date. So let's say we need images for 5 years. Okay, so give me your years. Give me. Okay, so we'll say now if you look at the documentation, let's just look at the documentation one more time. For date, right? There's a format in which it accepts the date. So it's year, month, then the day. And also you have to be careful about the day because if you let's just read the documentation, right? For the dates, it says the start date inclusive. So this is very important. So let's say we want from 2017. So you do this. So you say 2017, then you put a dash, then 01, that's like the first day, then first month rather, then 01. Now, it needs an end date. When, like my search, you want me to search, when do you want me to end the search, right? So again, we'll give it, what year, please? 2022? 2022, okay. Now, if you give it 1 again, that means you are doing from 2017 exactly to 21. That's why I said the end date is very important. 12? Okay, 12. 12? I mean, 31 or something. Or that's the last day. Or we can just do this 2023 and we can do 01, 01. So that makes more sense, right? Now, we can print the date filter, but if you print this date filter, I can still assure you we'll have an error. So it's calculating, and the error will pop up again because it's so much image within this time frame. So we still need to reduce this. It's too large, right? So the next filter we'll try is to filter by bounds, right? So filtering by bound means you want to filter to a particular geometry. Now, you could filter to your area of interest, or you could just use this, look at this, please. You could use this button to, okay, you know what? Let's just search, right? Let's search for Cassian, since we are in this city, right? So searching for Cassian, we have this geometry, and this geometry is to Cassian, I believe. But I can't see a point on the map, so I'll just delete this geometry, and I'll just put a point right here in Cassian. So basically, we can say, you know what? We don't want you to look for all the images we've had from 20, what's our time frame? Our time frame is 2017, 2023 to 2022. We don't want all these images, right? We want all the images just in Cassian, right? So the next thing is to filter by bounds, right? So I'll call this filter bound filter. And again, we'll call the image collection, right? So I'll just copy this. Image collection dot, then we'll say filter, right? Now, I want to ask you a question for just 30 seconds. So in this documentation, what do you think, what filter do you think we would use if we want to filter to a particular boundary? No, not you, please, someone else. Bound. Exactly. We filter to a particular bound. So if you click this, right, you can see what it's saying for you to do. All right, so sorry, this particular filter, bounds. All right, so let's call the filter again. So what you need is to call the ee.filter. So I'll look at this and I'll come to filter. So I don't want to type a lot, and I would look for the bounds, bounds here. Right now, if you look at the documentation for the bounds again, you'd see it accepts a geometry, right? So we give it a particular geometry, and which we've done earlier. Remember, we drop the point, right? So put this geometry, right? And would say bounds, right? So now again, let's see if we will get something meaningful, right? So let's print all the filter within a particular bound. So if we print this, let's see if we are going to get error or not. Finally, we found something. Great. So now it's not showing a lot of error, and now we have 1,1134 images within this collection. Remember, I'm not putting the time frame. I'm just saying since you started flying over the Earth, that's 2015, give me all the images in this area, and it found over 1,000 images. You could expand this to see the image properties. You see the features. You can see these are all the images, and you can also expand one image to see the other bands. These are the bands in each images. So it's a lot of image, and it's a lot of analysis we can do. Now, the last filter we'll talk about today is metadata, right? So metadata filter, and this metadata filter is what I was trying to tell you, that you need to go through the band descriptions, right? In this band descriptions, and you need to in the image properties and look at one of these properties, because you can filter with one of these properties. So now, please listen, because I want to ask a random question. We want to filter. And normally, if you're working with remote sensing data, you want your cloud to be less than 30%, 10. It depends on your methodology. If your methodology says 10, it's fine, but you would have reduced images. But sometimes if you say 30, you are saved, because if this is your area of interest, there might not be cloud in that particular place. But because you've said 10, then it's to negate it, and it's not with cloud. So 30 is kind of safe, right? It's a safe bracket. You could increase, decrease it. It depends on your methodology. So now I have two questions. The first question is, looking at this documentation in the filter, what filter do you think we would use to get out the image property? So we want to filter, right? We filtered by dates earlier. We filtered by bounds. And when we filter by bound, we got this result, right? So now, still a lot of images, right? Because obviously this is like over 1,000 images, which we don't want to work with. We want to work with images that are without clouds, right? So what filter do you think would need filter the images and negate the clouds? So now, if you look at this documentation, right? I want you to look at this documentation. This task is just 1 minute, and figure out what filter would we use to filter the images. Yeah. Cool. I don't know who would look. So I look now, it's alphabetical order. I can't see any M. So basically what you need to do is to just look at this filter, press it, and just to give you an hint, the property we are filtering by is the clouded pixel percentage. Just an hint. So we want to filter whereby the clouded pixel percentage is maybe less than something, greater than something, equal to something, So what filter do you think we are going to use? Remember when I was discussing with him, I was saying you could basically, he suggested 10, but I'm saying you could change your arguments. You can say your filter, we want a filter that, we want the cloud not to be more than 30. So what filter do you think we would use? We don't want the cloud to be more than 30. Greater than will give you, that's a very great direction of thinking. You're like almost correct, because but the thing is that if you're saying we want the clouds to be greater than 30, then we won't get useful images. So what would we do in this case? Less than. Exactly, thank you. So we'll use the less than filter, and you can also use less than or equals to. So if you look at this place, we have LT, yeah. So this is the filter. So now, basically, this filter, it filters the metadata, right? So now let's filter by metadata, and we'll call this variable, I'll just copy this meta filter because I'm lazy to type again. And again, we are working on the image collection, right? So we'll call the image collection again, right? After calling the image collection, the next thing we need to do is filter, the keyword filter. Then we pass the EE filter into it, right? So we say EE dot filter, and now we want to filter to autocomplete. Remember, it's the control and spacebar. So now I want to filter with the metadata, whereby the property of the metadata is less than a particular value. So we'll look for, so this is for greater than, this is greater than or equals to, GT is greater than, GTE is greater than or equals to. So we're looking for LT. So this is LT, and you can see it takes a name, right? Look at the documentation. It takes a name, that is the image property, and it takes a particular value, right? So we'll click this, right? I'm lazy, I don't want to type again, I'll autocomplete. So now, what is the name of the image property we want to filter by? Tell me.
I have the cloud coverage assessment and cloudy pixel percentage.
There's always a description. So you could read the description and tell me which one we'll be using.
Cloudy pixel percentage.
Definitely. So I'm copying this, right? And I'm going back to my code and I'll replace it with the name. And for the value, what value? 30. Okay, we'll just put 30, right? So now let's print. Now remember, this here we have 100 and over 8,000 images, and let's see what's going to happen now. So I'll just copy this again. I'm lazy to type, and I'll replace it with this filter, and then let's print. Sorry, I made an error. So what's the error I made? Anyone? No, not you. Anyone? What's the error I made? It says line 43. The cloud pixel is not defined. Exactly, it needs to be in quotes. So I'll just put it in quotes and just. All right, so let's run this again and it's computing. Okay, it gave an error again. Anyone knows why it gave this error? Why? Sorry? Yeah, why is it too much? I mean, the one above printed something for us. So why is this too much?
Because we're not filtering, we're looking at the whole world.
Exactly. We are looking at the whole world. So it's so much. So now what we can do, we can combine these three filters we've done, right? So now the next thing we'll do is to we'll string all these filters together. Filters. All right. So we'll have a variable and we'll call it. I'll just copy these filters, or let's say filtered, right? So all what I need to do is to just copy and paste, right? So now the first filter we had was the date. I'll just copy this, right? Then we'll change them together. So to change them together, we just need a dot, right? So I could put the dot here, just have a clean code. I'll put the dot here. Then we'll copy the next filter. Then we'll copy the next filter. So the next filter is this. We don't need to call the image collection again anymore because it's like the base thing we are filtering, right? So we don't need to like image, it's going to give us an error. So I'll copy this next filter, right? Where we are filtering to a particular geometry we on the map, right? So I'll paste it. Then the next filter again, we would have to put a point again, just to like change them together. Then I'll filter by the metadata. And now when we print this, let's see our result. So to print again, you press Control and Enter. So sorry, it's going to give an error again because I didn't change the name to filtered. I'm sorry about that. So I'll change the name to filtered and we print again. All right, so now you see it's collected over 1,000 image for our area of interest over time, right? But what we want to work with that is useful is just 48 images. Now, this is where in Google Earth Engine, basically, there's a workflow. After you filter, you can reduce, right? Then you can generate output, maybe a chart or a map or visualization, whatever. So the next thing we want to do is to reduce this image collection, right? We have, you know what? Let's visualize before we reduce it, right? Visualization. All right. So if we want to visualize, we would be visualizing on the map. This is our map area. So you need the keyword map, right? So I would say map, and it has to start with a capital M. Dot add. So you add a particular layer. We are adding a layer to the map, right? So you say map dot add layer, and if I also complete this, it says what is the object? What objects are you adding to the map, right? It also requires a visualization parameter, then the name, then shown, and the opacity. So this opacity and shown, you don't really need it. So I'll just remove it. You could put it if you want. Then what's the object? The object is this filtered, right? So we'll copy this as the object. We'll replace it. We don't have visualization parameter right now, so I'll just remove this. And we don't have a name. I'll just leave, or I can leave the visualization parameter as empty, like, and the name, I can call it filtered or something, right? And now if you run this, it should display something. You can see the layer is loading, right? And the opacity we were talking about earlier, you can use this button to like move. I can move the opacity and increase it. So now we see something loaded. But what is loading is black. Like, it's not RGB like the one that loaded earlier. Anyone has any idea why it's loading black? Like, why is it black? Like, I mean, satellite images are not like this. Any idea? Need to change the gamma for the layer. The what? Gamma. Gamma is more like brightness, right? So it's basically say like you want to increase the intensity of the brightness. It's not the gamma, but yeah, good point. Yeah, that's very good as well. So just let me go back to the code. If you remember when we did this, let me just write this again. Map.add, and let's autocomplete, right? And autocomplete again. We can see it's requiring us a visualization parameter. But here, I made it empty. So what it does is it automatically assumes, how do you want to visualize this? You didn't tell me. I'll use the first band as band 1. I'll use the second band as band 2. I'll use the third band as band 3. So if you go to the image properties here, you can go to the bands. So what it's doing is a combination of band 1, band 2, and band 3. And obviously what we need is RGB, band 4, band 3, and band 2. But even at that, right, it should still, even if it's giving us the wrong band combination, it should not be black. It should still show something, even if it's the wrong band combination. And that is because the intensity values are very high. And for us, are. So it's filtering it. And if I make this like this, you can see band 1 as like 2.3, 2300, and you can see all the band values. So it's capping that 255 value, right? So it's just saying, all right, man, it's too high, it's too like intensity is too high for me to display on the map. Then it automatically made it black. So if you click like anywhere on the image again, you'd see the values would show, right? But if you want to display this, right, let's say we just want to display something, you come to these layers, right? And there's a settings here. Then you click these settings, and from these settings, you can change this to band 3, band 4, because we want RGB, the red band 432, right? That's the combination. 4, 3, then you say band 2, right? Now, if I run this, it's still going to give me black. So what I need to do is, okay, what is the range? What is the range, right? So I'm just going to guess a random range. If you look at these values, the lowest is, let's say, without the QA bands, because the QA bands are basically to remove cloud cover. I don't know if you get that in this training. So now the lowest value, let's say 0, and the highest value when we're inspecting earlier, I'll just say maybe 3,000, yeah? 3,000. Then yeah, this is the gamma you were talking about earlier. We'll see it, but let me just apply this, right? Let me just apply this, and let's close. So it's because I applied it, it's going to run again. Then you'd see a visualization that is much better. So it's loading. You can see this layer part is loading, and now you can see it's RGB. So that is why it appeared black, right? And now if I copy this code, I get this link and I share it to you, like you run it on your local computer, it's going to go back to the black. So we need to give it a visualization parameter that, yo, we don't want you to keep going back to being black, right? So now we can give it a visualization parameter. So if you look at this, right, it's just the same thing that is here. We just need to code it out, right? And just to, sorry, you mentioned the gamma earlier. So look at this. I think this is too much, but if I apply this, it's going to get dark, and if I do this, it's going to get like really bright. So that's what the gamma is for, but you can like practice this on your own. So now you can also stretch the values. So if I give the stretch, it kind of does a standard deviation kind of thing, and it looks at the lowest value, the highest value, then the median value, then standardize everything, then it gives you a range, right? Look at the range. Then when you apply this, you see the visualization quite better. An object, a dictionary object, and now we have to give it some value, minimum value and the maximum value and the bands. So we can say mean, and we'll say mean value is 0, and we put a comma, and then the max value. So the max value is, I think we did 3,000 then. So we say 3,000, or I'll reduce it because I didn't like the visualization. I saw it was like, yeah, so I'll reduce it to maybe 2,500. And now we need to like give it the bands, right? So we'd say bands, bands, and this now takes a list, right? So I made a mistake here. I have a dot. That's why it's giving me that error. So I have to correct it to a comma. And now the bands, right? So if you want to visualize in RGB, you could put band 4, band 3, band 2. If you want to visualize in agriculture, you could just Google what is Sentinel-2 agricultural visualization. Then you put any band you want. So I'll just stick with RGB for here, and we'll say band 4. Then we would also want band 3. And finally, we want band 2, yeah? So now, this visualization parameter, right? I will just change it to, I'll just add RGB here. So we know what we are doing. It's RGB visualization, and I'll copy this and I'll put it here, right? And now we give it a name, filtered. So on this layer, it's called filtered. We can call it anything we want, basically. And now when we run this, I'll hit the run button, and the console is telling us something. Oh, we add some print function earlier, so that's what the console is saying. And now you can see the visualization parameter of what we add earlier. So basically, we've been able to filter this image, and we've filtered this image to our area of interest, and basically we've also displayed the RGB. It's currently loading. We've displayed the RGB values of particular place. So you could export this. You could do anything. You could anything basically you want. You could do with this entire thing. So I would give you a task right now, and Okay, you know what? Let me just turn this to a QR code, this so you can scan it and maybe use it on your computer. Because I want to give you a task, and basically the task is for you to um, I need to sign up to to do this. Sorry. All right, thank you for that. So how do I do that? I think this is the page. So what do we do? Maybe more tools. Ah, this Chrome. All right. So basically, what I want us to do is to look at this QR code. Right now, if you are with your computers, I want you to generate the RGB image of your hometown. So this task is for 5 minutes, and by 17:30, I would go around to see your results. So again, using this code we have in class, right? Generate the RGB image of your area of interest. Sorry, of your hometown rather. Sorry, not your area of interest, your hometown. And I'm recording this session, so after the class, I'll upload it on YouTube, and you can always watch it on the channel. If you don't have your laptop, please use your phone. That's the beautiful thing. Yeah, you can do it from your phone. Yeah. That's it. That's not computing. You don't even need a laptop. Imagine. It's much tougher. Something like Do we all have it? Do we all have the task done? Like, is the task done? Actually, we are 2 minutes over time. So let's continue here. All right. So I'm glad we. All right, guys. Welcome back. I'm glad we were able to display something for our area of interest. But what I just want you to know is that for your area of interest, right, what you might want to do is to come here and maybe apply some custom stretch so you'll be sure because in your area of interest, there might be reflectance values that are actually higher than this. So if you are using values that are higher than this, it's going to clip it to this and you might not get a good visualization. So what you want to do is to like come to the inspector and maybe click random locations and see what is the highest value. If the highest value is, let's say, 3,000, then you can use like 3,500 for the max. So if you are using this strict one, if you have reflectance values that are higher, you would not get a good result. All right. So now, guys, please listen. Please, I need your attention. So on the console here, we have 482 images. But what image is showing here? Please, I need your attention. We have over 400 images, but what image are we displaying? So basically, what it's displaying is the first. So what we can do is we can also do this print. Since our layout is what we are displaying, we can say there's a function called first, and that's what we are working with, right? So this is what we're displaying and stuff like that. But any of you in your area of interest have a lot of cloud. I want an image with a lot of cloud, and I want to show you how we can remove the clouds. You have a lot of clouds? Okay, what's your area of interest? Albania. Can you share? How can you share me your code? Can you just come, please? No, just come. You, not with your laptop. Just can you just type the geometry for me? I don't know where this is. Can you just type where this is for me? This is how to spell it. But all right, cool, guys. Please, yeah, you can go back. Thank you. All right, so I want to change geometry because in the introductory class, we're talking about how Google were able to like remove all of the clouds and create something cloud free for like the whole world. So let's like try to practicalize it here, okay? Please listen. All right. So I would just comment this out because we don't like need to print or add anything to the map. So I would add a new geometry. Please guide me properly. Your geometry is somewhere here, Albania. Like your okay. So I'll drop a. I just dropped a point there, and this will be like our geometry 2. So what I just want to do is that okay, sorry, let me delete this. Sorry, it combined them. So I'll create a new one, and I'll drop it somewhere here. And now I'll run the code again. So this is why Google Earth Engine is good, right? I've not done anything different. The only different thing I did is to, so imagine you have this code for flooding and you want to like check the flooding in another place. You'd see people who are just writing papers. This flood happened yesterday. How do you have the paper published already today? You have the codes already. All what you need to do is to just change the geometry and it works the same. Maybe your methodology might be different. Maybe a value, for example, in today's class, when we get to the flooding part, we are using in the methodology, there's a threshold of -3. And maybe your threshold is not -3. And you change your threshold and you have the results ready. Exactly. So I just want to change this to I want to change this to 3,000 because I'm not sure what the stuff is there. Then now I'll run this. And we made a mistake. I made a mistake. I didn't add it to the map. So I'll run it again. And let's see what pops up. All right, guys. So if you look at this image on the left-hand side, there's a lot of clouds. It's loading. You can see a lot of clouds. This these are clouds, right? This white thing. It's not snow, yeah? It's not snow, it's cloud, yeah? Okay, cool. I just want to be sure. All right. And if you want to be sure, you could just listen. If you want to be sure, I could just uncomment this and print this again. Then we'll go to the image properties. Then we'll see how much of cloud is in the image, right? So on the image properties, I can come here and on the properties we can see it has about 16%. Sorry, it has about 16% of the entire image is filled with cloud. Now, but let's also look at something for that particular area. We have over 200 images. Now, this is what I was trying to explain earlier. This is what Google did. You have over 200 images. Everywhere cannot be cloudy at the same time. What do you need to do? These white values, let's inspect it, yeah? Let's just press inspect and just click a random white values. The value is going to be very high, right? So this, you can see like these values are 3,000, sorry, 4,000, 6,000. You know, these are values with clouds, are areas, pixels that have cloud. That's why you see the reflectance there are very high. And the places with 0 or something would be where the cloud shadow is forming. So now the satellite is going over the same Albania over and over and over. So probably in some seasons that it's not, maybe the cloud is not there, right? We can get good pixels. Now, how do we get good pixels? What we need to do is to pass a median function, right? We need to take the median, right? So now it will negate all the I values because those I values we don't need them. It will take like the average. Average is mean. It's not taking the average. It's taking like the middle number, right? Like those are where it's actually representing the right class. It's not representing shadow because shadow will be too low. It's not representing cloud because cloud will be too high. So what we need to do is we can mosaic it or we can say a median function. So it's really simple. And on the documentation, there are reducers, right? So if I come here and I search reducers, yeah, you can see a lot of reducers you can use. So these are the EE reducers, and the one we want to use right now is the mean, right? Is the median reducer. So if you search, you find the median reducer. So these are the reducers. This is mean. This is max. This is median. You know. So to use this reducer, let's call this. So what we want to do, right, is the 212 images. If you look at this part, um, we have, I think it's 211 images, right? We want to turn these 211 images into one image. That is our end goal. So let me try to see if I have my paints. Uh, my laptop is misbehaving. Sorry about that. I just want to like illustrate something. All right, cool. All right, so this is my paint app, and let's say this is one particular satellite image, right? This is the second particular satellite image. Now, that's too big. Sorry. Now we have all this image dots, 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 and this is the last satellite image, right? This is the last satellite image. So we have, this is the 211th image we have. So what we want to do is we want to create one image that is free of cloud. So what we need to do is to take a composite. So a composite would use a reducer. It will use the median reducer. We can pass so many reducers. If you pass the max reducers, then probably everything will be white, right? Do you understand? No, not you. So what we want to do, right? So like your image has like a lot of pixels, right? Now let's say these are your images, right? Now, the first time the satellite passed over this area, this part of the image was cloudy. So all the values here would be very high. The second time it passed over this image, this part was without cloud. Still the same part, still the same geometry. We are not moving. It's still the same part. Then it goes like this for 211 times. Now that means we would have some pixels of a particular area that is cloud free, and we have some pixels that has cloud. Now those pixels that are cloud free is what we want to extract. The pixels that have cloud would have very high intensity values, like we showed earlier. We showed it here. So these pixels, look at them. I just randomly click the white pixel and we have very, very high values. The intensity values are very high, right? So what we want to do is that we want those days that the intensity value is the actual value and not this like very high value, or not the very low value. So what we need to do is to apply a reducer. And of the plenty of reducers we have, the best one to use for this purpose is the median, right? So it takes this high value, this low value, the middle, you know. So that is like showing the actual uh, intensity for that pixel. Do you understand? No one is saying yes. Do you understand? All right, thank you for saying that. I just want to be sure. All right, so now to do this, yeah, we would say so a composite, right? I would say composite. Now we filtered, right? Previously. So what we need to do is to copy that filter. Pretty simple, yeah? And we'll do something like this. Then you'd say median. This solves the problem. Google Earth Engine is super fantastic. Just this line of code solves the problem. If you want to go through the long routes, you can do something like this. This is actually is not the long route. This is the appropriate thing to do. So what I did earlier was a shortcut. So what you need to do is reduce. You say yeah, you say this reducer, right? Then you say, because I'm showing you this because you might see someone else write their code like this, but this is the actual right way to do it because we have so many reducers. But the popular reducer, like the min and the max, you can just write it and it will give you, what you want, right? And once we are talking about the Libya floods, when we get there, we'll need to use a reducer to calculate all the pixels, all the pixel values. Know what is the region, what is the like how many square kilometers is flooded, right? So you always need to write it like this. The one I wrote earlier was very lazy, right? Then you say EE, then you use the capital reducer dot capital R. Now, then you look for the mean, just the way we are doing the filter, right? But I don't want to go through all that typing and stuff like this. Median, right? Then you do the appropriate thing. But I'm lazy. I'll just say median, and I'll give this. Now, what we want to display is the composite. We do not want to display the filtered collection anymore. This composite has turned the 211 image into one. When we're presenting earlier, here, we said, look at this, right? Uh, we said it's been taking images since 1984. And it was Google was able to provide a cloud-free image of the entire world by creating a composite of the whole world, right? And I said we'll practicalize that, and that is what we are practicalizing now. And now you see how this cloud will disappear very soon. So now instead of adding the filter to the map, what I want to add is the composite, right? And instead of calling it filtered, I also want to call it composite, right? And I don't need to print the first because it's just one image. And now once you run this, you'd see Google do its computation and you see Google clear up, you see Google Earth Engine clear up the cloud for that particular area. Voila. We have a cloud-free image of our area of interest. Question.
What if, for example, you're looking at Mount Everest, which is almost always cloudy?
I don't know the cloud condition of where you just are, but you said it's almost always cloudy. That means there are some days it's not cloudy that the satellite will capture. Now, I was working recently on an area of interest, and after I applied this, guys, please listen. For his question, I was currently working on an area of interest, and when I did this median function, it was still cloudy. So, like that place you said, it was still cloudy. So what did I do? What I did is that the time frame I had was too short. I think it was just 8 images. And with 8 images, it's not really able to give you a good median computation to get a cloud-free image. So what you want to do for places like that is to get images that have like, when we filtered earlier, we saw over 1,000 images. So over that 1,000 images, there'll be time that the median got the particular area is free of cloud and you can use that part. So if you look at this, you see you have a relatively cloud-free image of the area of interest. Now, one more thing I want to do is this place is too big. Like obviously our area of interest would be a small shape file, a polygon. So if I want to be lazy, what I can do is click this and draw a box. But I don't want to be lazy this time and I want to show you something new. So on your search bar, search GAUL. It's a global administrative boundary. GAUL. It is global administrative unit layers. Then if you click this, the first one, you could click anyone. Then you need to again read about it, go to the band descriptions. And in fact, we could just copy this like we did earlier, right? And we paste this. So we paste this here. Please, can you close the door? The noise is coming from the outside. So I paste, what I did is just to copy and paste Google's code. This is not my code. I do not claim ownership of this code. And I just copied and pasted Google's code, right? And I'm going to hit run. I'm saying we should save this. So sorry, I didn't hit run, I hit save instead. So I would comment this away because I don't want to load the layer. So our work will be faster. Then I'll run this. And once we run, you'd see the shapefile of the old word load, right? So this is the shapefile of like the entire word. It's going to load again. And all what you need to do is to just select your area of interest, right? So I've taught you moments ago how to filter. So now what we need to do now again is to filter. This is too large. We don't need the whole word. We need to filter. Again, I'll use Casillon because we are currently in Casillon. So we need to filter this down to Casillon de la Plana. So I prefer importing this, like importing this because it makes my code look shorter, right? So imported as a table, but here it's called, I don't know what they called it. It's called dataset. So if I'm working with this filter, I'll just call it a dataset. And also you can convert this to, yeah. So, but I don't want to work with their data. So I'm just going to remove all of this. And let's say Cassian. All right, so I'm saying Cassian de la Plana. And now we want to filter this. The guy from Ghana, what do you think I'll do? I want to filter to Cassian. What filter would I pass? Like, what's the first thing I pass now? Sorry? Oh, Rwanda, sorry. Sorry. I want to filter to, we've done filtering in this class, right? So now the goal for me right now is to filter to Cassian. How do I make this work? Yeah, that's correct. But the first thing we need to do is to remember earlier when we were filtering, we were always calling the image collection. But now we have a table. So the first thing we need to do is the table, right? So we come here and we say the table, right? Then we want to filter it, right? And now we want to filter to a particular location. Then we say EE filter. And I want someone to remind me what filter would I be using in all this list of filters. So again, we have to go to the table schema and look at this. So we have the country name and whatever. So we'll be filtering with this admin name because it's going to, like, if I want to filter to Spain, I'll copy this admin name. So on the list of the filters, what filter would I be using to filter to my particular admin boundary?
Equal.
Yes, equal. I think it's level 0. Yeah, it's level 0. So we are going to use the equal. So you need to have a sense of like how would you be using it. Now, what is the name of the feature we are trying to, the name of the property is admin name and the name of the country is Spain, right? So let's saying error on close string. We didn't close the string. Sorry about this. Okay, cool. So now let's run this and let's add this to the layer. We'll get there. Just I'm trying to go from like the bigger picture to where we are going to. Okay. So I'll run this and let's see our results. So you can see we have the entire Spain in the results. So I'll just try to come to Cassian and Cassian should be somewhere here. I should up a little bit. So yeah, this is Cassia, right? So basically, I can click this inspect button and just inspect the particular polygon. So I click on the polygon and it gives me this feature, and you can come to the properties and you can see the name of that particular place I clicked. The admin name too is Casio Cassion. So I'll copy this and I'll replace it with Spain. Please, are you following? And I'll copy this name and I'll replace it with this admin name 0. So this is the admin name 2. And now once I run this, we should have just Cassion. All right, great. So we filtered everything down to just Cassion. So sometimes because my map is panned to Cassion, that's why we're having the result in Cassion. So the best thing to do is to have something like this, map.center. So basically, you are centering to Cassion, right? So you do this and you center it to Cassion, and you give it a zoom level. So we would say 8, and I'll run this again. Then if I share this code with you, every time it comes to Cassion, it doesn't like leave Cassion. So now what we want to do is you can also give this some funny colors just to play. So we can do something like this, say um, color, and we can say blue. This is just me playing around, nothing serious. And we can call this Cassion, and we can run this. Okay, so you see it's blue. So basically, this is just playing around with it, but we don't need any visualization parameter. So I'll just remove this. And now our aim is to um, clip whatever we've done, right, to our area of interest, right? So we can come here and we use right. So we can just try to clip what we've done so far to our area of interest. So this is clipping, right? And we will declare a variable and we would say clipped image or something. So clipped image, I don't know. You could give it any name. I'm not very good with the namings. So we have a composite, right? That we've done before. So we would say composite. Then we'll just give the keyword clip and we'll clip it to Cassion de la Plana. Then we run our code again, but I think we changed our geometry to Albania. So I'll just delete this geometry and I'll drop a new geometry here. Okay, you understand what I just did? Okay, now I'll run this code. And so now I want to copy this, right? I just want to put this here. And I don't want to show Cassion image. I don't want to show this. I want to show the Cassion image. And the visualization parameter, I want it to be the RGB vis we did earlier, this, right? And I'll paste it here. And I think this is good. So now once we run this, hopefully we don't have any errors. We have the Cassion loaded here and the image is loading. Yeah, it's just to like, we've performed some filters. I don't know if you are not here then. And we've performed in the filters, we had geometry there. Yes, we could have replaced it with, yeah, with the name Casio, yeah. So guys, Then the visibility we were talking about earlier, the opacity, this is it. You could just do this. I didn't remember to mention this, and you can change this to satellite, and you can see, like, yeah, this is quite correct. So the second task I have for you, I don't know the number of tasks, maybe third or fourth. So the next task I have for you is basically to do this for your own area of interest, and your area of interest is where you come from, and clip the RGB image to your area of interest. So we have 5 minutes to do this. Um, you know what? Let this be an assignment. Would I just check the time? We are running late. So, or you know what? Let's just do it for fun. 5 minutes, and let's start now. So in 5 minutes, let's do the task. Like you want the QR of this code? We've added to the code. We've added some lines, so I'll just generate a new QR. So you know what? Yeah, thank you so much for that. So I'll just save the script and I'll call it conference. And okay, so you could scan the previous QR code and it should still work. Um, the previous QR code should still work. Thank you very much for that. So the next thing after this would export our image. Then with this, you have like a basic knowledge of Google Earth Engine. And we'll leave the basics just a little bit. Unfortunately, we can't do the NDVI and stuff. I really wanted us to do it. Yeah, because we need to end this class in 30 minutes, right? To get to, it's not working. Okay, I'll get the link again. This, this, left. Dankeschön. We have a new QR. Please let me tell her we have a. So we all have this. I just want to. We have 2 more minutes. So all what we need to do is to just change the name from Cassion to your area of interest, and the geometry we've used. You have to change the point. So I've added 2 more minutes because of the delay we had earlier.
store the geometry inside of a variable.
Yeah,
Yeah, and to click that.
that's what we did, I think.
Yeah.
So if you look at this is the geometry, we stored it in a variable, and when we clipped with it. That's the same thing with it. And you could also, so instead of using this geometry, I could, just do this. Maybe because I noticed this part of the image is not showing, right? So the reason it's not showing is because when I click with this particular geometry, it's not taking the entire shape. That particular geometry is like a particular pattern row, right? So it's not taking the right geometry. So what I want to do now is to somewhere after my filter, I want to say Casillon is here, right? Or even what before my filter, I want to put this. So when I'm filtering by bond, yeah, I won't use the geometry anymore. I'll be using this. Is it clear? I'm doing this because the upper part, the northern part of the image was without images. You can see this part is without images. So now I want to filter. Okay, I want to filter with the exact stuff, right? So I'll just run this. I'm getting the signal that our time is almost up. We should round up. So I'll just filter with this. And now it should get the entire image of our area of interest and not cut the northern part anymore. So it's still loading, but it will be done very, very soon. So there's something I just really want to teach us because everyone does this normalized difference. So what we can do is this clipped image, right? This clipped image, please listen, you can do the assignment later. So this clipped image, right? We can say NDVI, and we can say is equals to, so the image we've clipped, then it's just very simple. The function is normalized difference, right? And you put the bands, band 4 and band 8 and band 4. You can see it's showing, now you can see it's like the entire image. So yeah, you put it in a list, you say band 8, and again band 4. So now there are so many normalized difference, right? It doesn't now, this is for NDVI. So whatever normalized difference you are using, you just change the bands, right? And sometimes, for example, SAVI, SAVI, you can't use normalized difference because it has an expression like 1.3 multiplied by, there's some differences you want to do, it has like an expression within it. So instead of doing this, you can also say, for example, right, then you'd say the clip image, then dot, I think the function is expression. So once you do this, you can put the expression. So if the expression is 1.3 multiplied by whatever, you can do this and you specify your band. But maybe this will be an homework for you because of our time is late. But this is just showing you that there's some normalized difference that have some values in it, So this is how to do it. You use this keyword expression. That's what I want to show. And now what we can do is to display the normalized difference, map dot add layer, and we add this NDVI, right? And there's this Moody's visualization I really like. So Moody's NDVI. I really like this Moody's NDVI visualization parameter because it's really great. I want the data from Google Earth Engine, sorry. So data sets. I really just want to search and go there immediately. I think this is it. So we'll copy their visualization and we'll use it to visualize our stuff. So I really like their visualization. So I'll just copy this visualization. You can also do this. And I'll come back to our code and I'll paste it maybe somewhere here. And I'll copy this, right? I'm being very fast now because we need to wrap up. I'll paste it here and I would say NDVI and we'll run this. So I'll just off the other layer so the NDVI can load. You see the NDVI of your area of interest. It's loading just some moments. It's going to load. So that's how to do normalized difference. And I have a script. So while it's loading, let me just, I've saved it. This is the NDVI for the old Casillon, like in real time. It's like really awesome. Loaded up for you. It's still loading, but give it some moments, it would little more ambition. So I've prepared, this is it, and you can like inspect the values and you can, play around with, this. So I have a script, I have a script here, and the script is basically, so this is it. And now you can turn this NDVI we have here. You can, where's the script? Where's the line? Yeah, you can just pass this to a function. Just use the keyword function and put this in your function and say return this. And now you can do this for an image collection for 30 years, for 10 years, for 2 years, and you get the NDVI for every month. So it's really awesome, right? So this is the last thing we'll be doing in this class, and I'll just explain this code for you. So we needed to go through like everything we've done so far so we can like know how we got to this particular code. So if I run this, the place the code happened, sorry, the place the flood happened is Denera. We remember we did something like this, whereby we have an area of interest and we can filter to where we want. Remember this, right? So that is what I've done. So that is what I did here. So basically, I filtered to this place, and after filtering to, I didn't teach you something, I forgot, and that's why this tax is popping up, and that is how to export. But that will be an assignment, so you do it on your own. Then after that, I filtered the image collection. So now we are not using Sentinel. We're not using the optical images, right? We're using the Sentinel-1 SAR. So you could like just say Sentinel and you'd see the SAR Sentinel-1. So this is the data set we are using. And if you go to this data set, you'd see the bands we need to use. And we need to use this VV band. And if you go to the band, you see, yeah, this is it, VV band. And the VV band on the image property, it is under, it is under this particular transmitter receiver polarization. So we need to just filter it properly, and that's what was done here. So we filtered the bounds, right? We filtered the band to Denera, which is where the flood happened. And after filtering the band, we filtered and we selected this particular band that is like of interest to us. And after doing that, we filtered by date before the flood and after the flood. So remember how we spoke about EE date filter in the past? So this is what we did. And also after doing that, I just mosaiced it. It's just like the median we did. We mosaiced and we clipped it immediately. So before we were like doing the clip, but now I just did everything on a single line to make the code short. And after that, there's a visualization parameter for the before image and the after image. So if you come here, this is what the image looks like. This is what the image looks like before the flood, and after the flood, this is what the image looks like. If you zoom in, you'd see some differences. For SAR images, the areas that are really, really dark are the areas that the flood occurred. And after doing that, because there are always noise in the SAR image, we needed to like perform a smoothing, so our model would be better. So this is the code to perform the smoothing. And after the smoothing, right, we smooth for the first time frame and the second time frame, then we need to perform a difference. So when we did the NDVI in the previous scripts, you can also do NDVI for maybe 2023, NDVI for 2022, and you can just do this subtract. Then you see like what the difference in the vegetation has been over time, right? So this subtract function does would now leave the areas that we think are flooded. Then we need to set a threshold. So the material I'm using, the threshold was set to -3. I remember when we were passing the filter, then we're using dot LT. LT means when it's less than. LTE less than or equal to. So we pass this filter when the threshold is less than 3, we need -3, we need this. Then we also so now when you set this filter, then it's like an image of 0 and 1. 0 false, 1 true, right? Now you need to update that mark that, oh, we need just the true values, right? And this is what was done here. So we updated the marks and we just put this value in it. Then now the difference, so this is the before and after, then this is the difference layer. So the difference layer is going to load, right? So this is the different layer and that is what I've done here. And after that, we did this flood, right, to detect the areas that are flooded. And the areas that are flooded is what I've written, I've had in this flood. And you can't really see it, but let me zoom. And once I zoom, you'd see like some pixels that are like blue. These are the areas that the flood occurred over time. And now we need to quantify this, right? We need to quantify the flood, and that is why we spoke about the reducers when we were doing the lecture earlier, right? And we particularize the main reducers that remove the clouds from our image. Remember? So now, yeah, we wanted to calculate the flooded area. So we want to get the numbers of pixel, and the reducer we are using here is the sum. So basically, what this reducer is doing is that every area and the pixel, right? Every pixel has a particular size, right? And we've like gotten the area with this particular line of code. So we've gotten the area, right? So now this reducer is to add all those areas, all those pixels together. And after it has done that, this is that, right? Then we printed the results, and this is the result here in an object, and this is the total area in square kilometers, I think, in square kilometers for the flooded regions. And the final thing was to export just the flooded area. And now there are also some reducers that can convert your raster to vector. So you can like convert this vector. If you come here to reducers and you look through all these reducers, there's a particular reducer that converts from raster to vector, and I can't remember the name right now, but I know there's a reducer that does that. But you get the idea of what I'm trying to say. So at the end of the day, we have our area of interest and we have everything so far. So I would give my email address, or I don't know, on the website, my email address should be there, I think. But it is babatunde@remote22@gmail.com in case you have questions, because we need to like end the section right now. So I hope you enjoyed the class and I hope you learned one or two things. Thank you. I want us to take a group picture. Yeah, we have to. Like a picture, Chris. You have to say, oh yeah, nobody's missing from mine. Okay. No, but he's missing. Okay. Okay. Say cheese. Okay. Cheese. Cheese.